Ready? What do we have for electricity? When am I write down for that? Sure. And voltage measures.
The force in which the electron moving through the conductor.
What's a water analogy?
Gradient.
How about pressure? Okay, and ampere? Okay, I don't mind flow rate. So we're actually talking about number of electrons that pass a given point in a second. So when you think about amperage, you're just talking about the number of electrons going. So we talked about this wall outlet here probably being a 20 amp breaker. If I send any more than 20 amps through this outlet, then the breaker behind it should trip because this wire isn't big enough to handle that much current. Because remember, when current runs through a wire, it produces heat. So if a 20 amp outlet has 30 amps running through it and the circuit breaker doesn't pop behind it, then those wires will get so hot. What's going to happen? The insulator will melt, and then the positive and negative will touch each other, and then you'll have massive electron flow, which will catch anything near it on fire. All right, AC/DC, what's the difference?
AC is alternating current. Moves back and forth.
I'll say that. And DC.
Just like AC, like because it fluctuates back and forth like periodically, right?
60 times a second under normal circumstances. Unless you're in the Soviet Union, then it does it 50 times a second. So if
I was just reading somewhere, it was like kind of mentioning periodic function, sort of.
It's definitely periodic.
Yeah.
It goes through a sine wave. If somebody was just standing next to you and you had your arm out and they were rubbing it across your forearm, your hand would get hot, or your arm would get hot, right? What if instead of one person, a bunch of people just walked past you? Each one was doing that. It's still going to heat it up, but one's going one direction, one's going both directions at the same time. Even though the alternating current, even though it's doing this, it's more like this. It's still making its way down the wire, but it's going back and forth as it's making its way down the wire. It's like 3 steps forward, 2 steps back, 3 steps forward, 2 steps back, giving you a nice sine wave that you get from trig geometry. Where's AC used?
Generators.
All the power lines, those are all alternating current. The electricity running through your house, through businesses, through the school, that's all alternating current. Your car produces alternating current and then converts it into direct current. Okay, so how about the direct current? So anything that needs a battery is going to run off of direct current because batteries aren't alternating, they're just in one direction. So just in general, electronics cannot run off of alternating current, which is why all electronic devices that are plugged into your alternating current outlet have one of these things that this switches it from alternating current to direct current. All right, write any single rule replacement reaction to identify the substitutes oxidase. Okay, so give me a metal. Lithium? All right, fine, that's good. Give me a salt. Okay, go easy with this. So what do we end up with? I mean, aqueous is probably a bad term, but I don't have another term for you. And then solid sodium. So what's the lithium's oxidation state here at the beginning on the product or reactant side? 0. And the sodium on the product side is 0. The sodium here is a plus, and the lithium here is a plus. The chlorides are both minus, but they don't change. So the chlorine in this case is a spectator ion. So who gets reduced? Whose charge went down? The sodium went from +1 to 0. So the sodium is reduced. And then, so that just leaves you with the lithium oxidized. There's buttons on the stupid pen that make you erase stuff when you touch it wrong. Okay, which is a more rustable metal, the magnesium or the aluminum? How do you know this? Where do you go look? Periodic table? No.
The one that shows which is more active or not.
Yeah, what do we call that table?
The oxidation reaction.
I don't hate any of those words, but that's not what it's called. Just activity series. So any activity series can say, so you just find magnesium and you find aluminum. Magnesium sitting on top of aluminum in this. So who's more likely to lose their electrons? Magnesium. Okay. So then we have magnesium is more rustable because it's more active, which means more. Did that this morning too. More likely to lose its electrons. Okay. Acid has the ability to do what to some, but not all the metals. What is it they do to the metals? What do we got? Okay. What happens to the hydrogen? Sodium, it's fine. So the sodium is oxidized, right? So that means I end up with a sodium with a plus charge. So what happens to the hydrogen? Just becomes hydrogen atom, but since it's hydrogen, there have to be 2 of them. So they end up having 2 of all these things. And then this just turns into a gas. So what's going to happen when you drop an acid on most metals? Dissolve is okay, but how are you going to notice? There's going to be some bubbling. Yeah. You guys did this at least once where you put magnesium ribbon metal and you put hydrochloric acid on it and it bubbled. The bubbling was hydrogen gas being generated. Oh, well, all right, fine. Then there's the answer to the next one. There's the equation. All right.